All right, this video is going to go cover the beginning of our little lesson on inequalities, just because I'm not sure what maybe people remember from sixth grade. So this is the do now. We're just practicing graphing the solutions to each inequality. So number one says x is less than 5. So we are graphing all of the numbers less than 5 and remembering that 5 is not less than 5. So we would have to have an open circle. Sorry if this is a little messy. I'm using my mouse, not my iPad, which is not easy. So we would have to have an open circle on 5 and then our arrow would be coming down for all of these numbers. All of these numbers are true for x, right? -7 is less than 5. 3 is less than 5. 0 is less than 5. 4 is less than 5. 4.5 is less than 5. 4.999 is less than 5. All of those numbers, not including 5, are less than 5. So they would all be solutions for x. X is less than 5. And we would do the same thing for all of these. All of these are greater than or less than. So all of them would have open circles. On number 3, x is greater than -6. So again, our circle would go on -6. It's going to be open because -6 is not a solution. Wow, look how perfect that circle was. All right, x is greater than -6. So these are all the numbers greater than -6. All right, moving on. Oh, these not erased. Let's see. All right, so just a reminder of all of the symbols. This, of course, means less than, greater than, less than, or equal to. So if we were graphing these on a number line, we would have, instead of having open circle, we would fill that circle in to include whatever number we're talking about. We would, again, same thing, fill that circle in to include whatever number we're talking about, less than or equal to, greater than or equal to. Whereas on the greater than or less than, when we're graphing those solutions on a number line, we would keep these open circles. So today's lesson is going to cover solving inequalities and then graphing the solutions. So just like we solve equations, we can solve inequalities. But on this screen, let's just talk about what numbers make sense. These are all one step, very simple, right? So here we're saying x plus 4 is greater than 10. So what are some possible answers for x? Could x equal 3? What is 3 plus 4? Is that greater than 10? No, it's not. So this could not be a solution. So what about 5? Could x be 5? Well, 5 plus 4 is 9, so no. So we're looking at these numbers that could be greater than 10. Could it be 6? 6 plus 4 is 10, not greater than 10. So we're looking all the numbers above that, right? We could say 6.5, right? 6.5 plus 4 is 10.5. So that's a solution. 7 is a solution. 8, 9, 10, right? On and on and on. So all of those numbers would be solutions. So we could say then that x has to be greater than 6, right? X cannot be 6. We already said 6 is not a solution, but 6.5, 6.1, 7, 8, 9, right? X is greater than 6 would it be our solution. So taking a look at some of these, we can talk about maybe one of the ones that is uh, less than or equal to or greater than or equal to. So taking a look at x plus 4 is less than or equal to 10. So here, could we say 6? Does that work here? Well, 6 plus 4 is 10. So yes, in this case, it could be 6 because we are saying less than or equal to, and 10 is less than or equal to 10. Could x be 7? Well, 7 plus 4 is 11, so no, it could not be 7. But it could be 6, right? It could be 5. 5 plus 4 is 9. So again, that's less than or equal to 4, 3, right? Could be all of those numbers. So in this case, we would be saying that x has to be less than or equal to 6, right? We said it could be 6 because 6 plus 4 is 10. That is equal to 10, so that works. Notice how in our solutions, our inequality is facing the same way in our original inequality and in our solution, right? That did not change. So it's almost like you're just following the steps of a one-step equation, right? I could say here, what do I do? Well, I know I want to get x alone, so I'm going to subtract 4 from both sides. That's going to give me 0 over here, and I'm left with x is greater than or equal to 6. And we can check that solution, right? If x is 6, 6 plus 4 is 10, 10 is greater than 10. X has to be greater than or equal to 6, so 7. 7 plus 4 is 11. 11 is greater than or equal to 10. So both of these solutions work, and we can keep going, checking all of those solutions that are greater than or equal to 6.